Is it possible to get something from nothing? This is the story of a very important number, but a number that wasn't always a number. In fact, it was much less than a number until relatively recently. This is the story of zero, and it's a story that takes a tortuous and meandering route through 1,500 years of human history. Today, we enjoy zero in all its glory, where it takes on two roles. The first is as a placeholder within our positional number system. Zero notes an absence of a value and allows us to create huge numbers without the need to create new digits. So we know 30 is larger than 3 and 300 is larger than 30 and 3. The second use of zero is as a number in its own right, the middleman, if you like, between positive and -1, and enjoying nearly all the same benefits as other numbers. We can subtract, add, multiply by zero, but dividing by zero just doesn't work. For example, you can't divide one chicken by no chickens. You might suggest the answer is infinity, but it's not, because infinity isn't really a number, it's a concept. Mathematics developed from a very practical desire to count things, such as the passage of days or the quantities of chickens you owned. To manage this, ancient civilizations developed rudimentary number systems. For example, the Babylonians used two symbols in different arrangements to create unique numbers 1 to 60. The ancient Greeks and the Mayans also developed their own number systems, and all of these civilizations are thought to have created their own rough concepts of zero as a placeholder. But it wasn't until the Indians began developing their own number system that zero would be defined explicitly. Their early number system would also evolve into the one that we use today, initially with 9 number symbols and then a small dot used to mark the absence of a number. In the 7th century, mathematician Brahmagupta developed terms for zero in addition, subtraction, and division, although he struggled a bit with the latter, as would academics for hundreds of years to come. As the mathematics of India matured, it found its way eastwards to China and westwards, influencing the Islamic and Arabic cultures where it was instrumental in trade. But zero found resistance in Europe, as the Hindu-Arabic system was opposed by the Roman Empire's established numeral system. However, by the 13th century, academics such as Italian mathematician Fibonacci were championing the new number system in their work, helping zero to gain a solid foothold across Europe. Over the next 400 years, as mathematics evolved from practical applications to ever more abstracted functions, zero would form the cornerstone of calculus. Calculus allowed anyone to break dynamic systems down into smaller and smaller units approaching zero, but cunningly avoided the trap of having to divide by zero. Zero had now become a celebrated tool in the mathematical arsenal, and as the binary numerical system formed the foundation for modern computer programming, zero once again stepped into the limelight to prove its worth. And so it seems, after all this time, it was finally possible to get something from nothing.
Ten years ago, there was a group at MIT which showed that you can look through a closed envelope with terahertz waves. And that was really inspiring to me, and I was like, if you have the time resolution of the terahertz spectrometer, now you can actually look deeper into multiple pages. I was really curious. I wanted to know how deep you can actually read through a closed book, because nobody has tried that. In order to read through a closed book, you have to do 4 things. First, you have to have a radiation that goes through the paper. So the paper has to be slightly transparent in this frequency range. Second, you have to have the time resolution to distinguish between different pages. Femtophotography was a project that opened the gateway to numerous projects that we have done in our group. With advancement in the time resolution, we were able to take a look at objects which have much finer details. With this time resolution, we can actually separate the pages. We can look at very, very small objects. The pulse that you send in is going to be reflected from each of these air gaps after each page. And we try to separate the pulses that are actually from this air-paper boundary compared to the noise that is coming from the rest of the sample. Third, you have to have the spectral information of different inks. For example, the ink should be visible in that range of frequencies. And the fourth one is recognizing the characters themselves. There is a shadow of different letters on top of the next page. So the algorithm has to be able to recognize the characters, although some part of the letters is missing. So right now we can see through 9 pages of the closed book because we don't have enough power and signal-to-noise ratio. And with advancement of technology, that would improve significantly so we can see deeper through the book. One of the applications is studying or doing inspection on antique documents. It's like an ancient book or whatever, and you cannot even touch it to open it and see what's inside. You can get some information about the layers with X-ray, but you cannot get information about the content, like what is written in this book. Our ultimate mission in camera culture at MIT is to make invisible visible, and time resolution is an essential part of doing that. I really like reading from the screen, but there are some of the books that I have to have. For example, The Physics of Impossible from Dr. Michio Kaku. And the reason for that is that I think it's both inspiring in terms of like science and also in terms of how capable humans can be with technology.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.